Hello students, welcome back to MathFace Java programming tutorials. In this video, I'll be discussing variations of a for loop and series programs using for loop. Let's see the contents: flow of control of a for loop, variations, series, introduction, simple sum of series with float data type, then double data type, positive and negative sum in the series, then Java programs. Flow of control of a for loop. First of all, initialization, then condition gets checked. If the condition is true, body of the loop will be executed and updates the loop control variable. Again, condition gets checked. If true body, then update. This process continues. But if the condition is false, the control is transferred to the next statement after the loop. Variations, we can have different variations. Initialization before the loop. In that case, that semicolon in for loop is a part of syntax, whether you initialize or not. See the example, int I is equal to 1. That is initialization before the for loop. And inside the for loop, semicolon. That is a part of the syntax. I less than equal to n condition, semicolon, I plus plus. Based on this for loop, there is one statement, body, system.out.print, I plus some space. So if input n is 3, this for loop works 3 times, fourth time false. All 3 times it is printing whatever is there in I. I1, then 2, then 3. All 3 are printed, 4 false comes out. The second variation is infinite loop. For semicolon, semicolon, and then body. This statement hello will be printed infinitely unless break is used. If we want to use break, then a block should be there. Inside the block, some condition. Based on that condition, break should be used. Then third variation is updation part inside the body. We have seen initialization before, now updation in the block, just like while loop. But int I is equal to 1 for semicolon, end of initialization part, whether we give or not. I less than equal to 3 semicolon, no updation given, but system.out.print I, then some space, I plus plus, block is compulsory in this, the output is 1 to 3. Then fourth variation, multiple initializations can be there and multiple updating statements may be there. How do we give? Before the first semicolon, we give all the initializations with a comma. For int I is equal to 1, comma j is equal to 2. That means 2 variables declared and initialized. Then I less than 3, that is the condition, semicolon. Then 2 updations separated by a comma, I plus plus, j minus minus. I was 1, I plus plus becomes 2, then 3 comes out of the loop. J was 2, j minus minus 1, and then comes out of the loop because I becomes equivalent to 3 then. So output would be I is 1, j is 2, I less than 3 true, so I and j print 1 and 2. Then I is incremented, j is decremented. Now I is 2, j is 1, printed. Now I becomes 3, which is condition is false. I should be less than 3, not equal to 3, comes out of the loop. Similarly, the next one, multiple conditions can be given with and or operators. Logical. Now two initializations, two conditions clubbed with and two updations. So for int I is equal to 1, comma j is equal to 2, semicolon, I less than 3 and j greater than equals to 1, semicolon, I plus plus, comma j minus minus. Two initializations, two conditions, two updations. Initializations are separated by comma, updations also separated by comma, but condition should be clubbed with either and or. The output is similar to D part of the program. Now no output because the condition first time only false. For int I is equal to 5, semicolon, I greater than 5. If initially I is 5, I can never be greater than 5 first time. So there is no output and body will not be executed even once. Then empty loop. Semicolon at the end of for loop is known as empty loop. For int I is equal to 1, I less than equal to 5, 5 times it is supposed to work, I plus plus, semicolon is there. That means based on for loop, the body is not there. System.out.println is not a part of the body only. This for loop empty works 1, 2, 3, 4, 5, 5 is less than equal to 5, 6 comes out. But when I print system.out.println I, it gives an error. Why? Because the scope of variable I finished at the end of the for loop. It is a local variable to the for loop. And the for loop is an empty loop. So gives an error, I not found. But if we want to print the last part of it, how many times it has worked, declare int I before the for loop. That means this I is available to the program, not only for loop. Then for I is equal to 1, I less than equal to 5, I plus plus, semicolon, empty loop, works 5 times, 6th time it is false, comes out, but I has the scope of all these 3 lines, so it prints 6 over there. Output would be 6. Now series introduction. Now introduction to series. Series is a list of numbers or letters in some order or format. Generally, a formula is used to generate the series. And it's very easy to generate series with the help of loops. And for loop is used to generate series because we know n number, like 1 to n we need to generate. Definite. And the programs like displaying natural numbers, odd numbers or even numbers and cubes of natural numbers till n or squares, anything. If you see natural number series are 1 starting from 1, whole numbers starting from 0 and negative numbers from -1, and these are all known as integers. This is list of numbers. Letters also we can create series. Now, simple sum of series let's discuss. Display sum of natural numbers till n. Sum of natural numbers. So let's assume user input n is 4. And we are running a loop from 1 to n. Definite loop. And for storing sum, we need a variable before the for loop, which should be initialized by 0, so that whenever we say plus, 0 plus will happen. See the dry run. For all the iterations, n is 4 only. I starts from 1 to 5. 5 is false, so comes out of the loop, but 1, 2, 3, 4 true, because our user input is 4. Now the statement based on for loop is sum is equal to sum plus I. Sum was initially 0. So sum plus I is first iteration 1. 0 plus 1 is 1. Now sum contains 1. Then second iteration I became 2. Sum is equal to sum plus I. Sum became 1 in the first iteration. So we take that 1 replaced. 0 is replaced with 1. Now 1 plus I, that is 1 plus 2 is 3. In the third iteration, sum is 3, I is 3, 3 plus 3 is 6. In the fourth iteration, sum is 6, but I is 4. So 6 plus 4 is 10. Such kind of programs you can practice. That is from chapter 8 from basics in computer applications book and practice exercise 9. Now let's see the same program in the Java environment. Sum natural, scanner, enter a number, n will be accepted here, sum is 0, sum of I, first time I 1, 2, 3, 4, sum plus is equal to I, some extra lines we are writing, sum of 1, 2, 3, 4, whatever numbers is, sum is calculated here, that sum variable we print here. So control K and then execute sum natural. Okay. Let's suppose we are giving enter a number that is 4. Sum of 1, 2, 3, 4 is 10. That is 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. That is the output. Let's go back and see the next sum of series. Sum of series with float data type. 1 upon 2, 1 upon 3, 1 upon 4, like that till 1 upon n we want to add. Now 1 upon 2 means integer divided by integer is integer only, implicit conversion. But we get the answer 0.5, 1 upon 2. So we need either float or double variable. First, let's see with float variable. Let's assume input n is 3. Float sum is equal to 0.0 f. All float variables should be initialized with f, either capital or lowercase. Now try to read n. I is equal to 1 to n, that is n is 3, I plus plus. Sum plus is equal to 1.0 f upon I plus 1. Why? Every time 1 upon 2, 1 upon 3, 1 upon 4. That means my loop should work 3 times. But every time 1 is the constant, that is literal. So every time we are saying 1.0 f upon I initially 1, I plus 1 becomes 2. When I is 2, 2 plus 1 temporarily becomes 3. We are not storing in I. Then 2 plus 1, 3 and so on and so forth. N is always 3. my I becomes 4 then false, otherwise 3 times it is true. Then sum is equal to sum plus 1.0 upon I plus 1. Now initially sum is 0.0. 1.0 upon 2, I plus 1, I is 1, 1 plus 1 is 2. So 1 upon 2 is 0.5. Next time we take 0.5 as sum plus 2 upon 3. Sorry, 1 upon 3. 1.0 upon 3. So 1 upon 3 means 0.333 and 0.5 which was there in sum plus 0.333 is equal to 0.8 something. Then I becomes 3. Then 1 upon 4 this time because I is 3, 3 plus 1 is 1 upon 4, that is 0.25. So 0.83333 is equal to 1.08333. Let's see the program in the Java environment. This is the program. Reading a number, n, float sum is 0.0f, then sum of the series is 1.0 upon I plus 1. This is the output. Let's see the execution, compile, and then main. Okay. Enter a number, let's say 3. So sum of 0.5, that is half. 1 by 3 is 0.3334. And then 1 by 4 is 0.25 is equal to this particular sum. Now see sum of series with double data type. X upon 1, x upon 2, x upon 3 till x upon n. 2 inputs are there. Let's assume n is 3, x is 2. Double sum is 0.0, no need of f because it is a double data type. Reading x and n, running for loop from 1 to n. Then sum plus is equal to x upon I. In the previous program we said 1.0. Here we cannot say x.0 or I.0 because both of them are variables. So we used explicit conversion. The x should be temporarily converted to double. That means 2 becomes 2.0. X is always 2 in the program. N is always 3 because inputs are like that. Now x upon I. I is 1 first time, second time 2, 3, 4. See the dry run. First time x upon I is 2 upon I, that is equal to 2 only. So 0.0 plus 2 becomes 2.0. Then 2 upon 2, that is equal to 1. 2.0 plus 1.0 equals to 3.0. Then third time x upon I, that is 2 upon 3 is equal to 0.6666. So 3.0 plus 0.666 whatever is equal to 3.6. And practice exercise 11 has so many practice questions. Let's see the same program in Java environment. Sum double. Here x value, n value red. sum is equal to 0.0. I is equal to 1, I less than equal to n, I plus plus, system dot out dot println, x upon I, what is it we are printing, and then adding the same thing. Then printing. Let's execute this program, double void main, enter the value, x is 2, n is 3, let's suppose. So, sum of 3.0 first time, then 1.5, then answer is 4.5. X upon 1, that is 3 upon 1 is 3.5. Then 2, n is 2 only, 2 times it has to work. So 3 upon 2 is 1.5 and total sum is 4.5. Positive and negative numbers in series. See here 1 minus 2 plus 3 minus 4 till n. Let's suppose n is 3. Here we have a condition in such a way that all odd numbers are being added and all even numbers are being subtracted from sum. Let's read n is 3, let's assume. This for loop works 1 to n times. See the dry run. N is 3 always. And then I is 1, 2, 3, fourth time false. First condition, I less than equal to n, 3 times true. Then next condition, if I modulo 2 double equals to 0, that is even number, even term, then sum is equal to sum minus I. Else sum is equal to sum plus I. So two conditions. One is I modulo 2 double equals to 0. Second one is else. Else means I modulo 2 double equals to 1. That is odd number. In even number we are deducting. In odd number we are adding I. First time I is 1. It is an odd number, so we are saying sum initially was 0, 0 plus 1 is 1. Sum became 1. In the second iteration, that I is an even number. So I modulo 2 double equals to 0. So whatever is there in sum minus I. So 1 minus 2 is equal to minus 1. Third time, it's not even number, so goes to odd. It is true. Whatever is there in sum, that is minus 1 plus 3 is equal to 2. And practice exercises based on this concept is there in chapter 8. Please go through. And then let's see the program in the Java environment. The same program, I is equal to 1, I less than equal to n is red. If I modulo 2 double equals to 0, then minus, else plus. Then when you see the output, enter the value of n, 3, sum of series is 2. This is about sum of series, simple series programs. Refer chapter 8 of Basics in Computer Applications for further understanding and practice exercises. The next video is about the while loop in Java. Thank you.